In this video I'll present ComBE, a combined editor, textual plus graphical, for behavior engineering. The textual editor is made in the language workbench SpoofX and the graphical editor is based on GMF. The EMF meta model that is underneath the GMF editor is generated from the SDF grammar, and instances of the grammar and meta model are being synchronized in real time by generic text-to-model and model-to-text transformations. Both the textual and graphical syntax of ComBE is similar to TextBE. For those who are not familiar with TextBE, TextBE provides a textual editor for behavior engineering and converts the textual representation into a graphical visualization. TextBE is now the main tool that is being used in the academic community to model behavior trees. Before TextBE, there were different approaches that focused on creating graphical editors instead of textual ones. So the main difference between ComBE and TextBE and the other approaches is that ComBE provides a synchronized textual plus graphical editor. And because ComBE has the same textual syntax as TextBE, it is possible to open existing .pt files. One thing to note is that the underlying meta model of ComBE is a bit different than TextBE's one. First of all, because it had to suit GMF, and second of all, because it is generated from a grammar, and that means that patterns such as multiple inheritance won't occur. Now I will first show you the features of ComBE's textual editor and show you how the graphical editor reacts on changes in the text. First of all, ComBE has some useful editor services that are not there in TextBE. As you can see, there is syntax highlighting, making it easy to distinguish identifiers from labels. There is code folding. There's reference resolving. So if we press Ctrl and click on this requirement, we go to the definition. And same for component behavior. There's also error checking. So if we make a 1 of this one, then there are two definitions that use 1 as identifier, so we get a duplicate definition error. And there's also an error when there's an unresolved reference. So I'm able to resolve this one. The interesting part is the text-to-model transformation, and I can best show you this by example. So let's start with a new tree. As you can see, the node immediately pops up in the graphical editor. And we can now, for example, change a label over here. Add requirement traceability, which changes the color of the node. Add a label and some operator. We can create a sequential composition. Let me just copy this node. Or atomic composition. And we can create branches. We can do an auto layout so that you can get a nice tree. One thing to note is that if you have an unresolved reference in the text, it will simply not show this in the model. So I'm now going to show you the graphical editor in more detail. First of all, by using GMF, you'll get a rich set of standard editing features for free, such as auto layout that we've already seen. It's also possible to only auto layout a selection of nodes. You can add a grid and make nodes snap to the grid. You can zoom in or zoom out. You can attach some node to an object. You can hide a selection of nodes. There's also support for printing. Again, the interesting part is the model-to-text transformation, and I'm going to show you this by creating a tree with the graphical editor. So let's start with deleting this part of the tree. And now we create a second node. As you can see, nothing happened in the text at this moment. That's actually not an error. In the meta model, there's actually only one tree, and in the grammar as well, but we are still able to draw two trees. Actually, the top one is the actual tree, and the second one is something what the GMF community calls a phantom node. So that node is only there temporarily to be connected to the tree later. And that's what I'm gonna do now. And now we see something changed in the text. First of all, there should have been a semicolon here. It's just a bug that needs to be fixed. And then we see that an X, another X, and a 0 appeared. The first one is the requirement, the second X is the component, and the 0 is the behavior. So even though in the graphical editor we didn't set values for those yet, so here we have a property view where you can set values for those references, we still add default values in the textual editor, because otherwise the compiler won't be able to parse the file. At least now it parses and it just gives some errors because there are unresolved references. So we can either set these references using the textual editor or using the graphical editor. So here we can choose a component, and then we can choose behavior. One thing to note is that the behavior you can choose from is indeed a set of behavior that is like underneath the component over here. So if we would select component 4, we can only choose from behavior 1. We can delete some nodes and create an alternative branch as follows. Some nodes, connect them, and add them to the tree. And there we are. That's all I wanted to show. Thanks for watching.